Okay, so in this short tutorial video we'll be having a look at calculating braking force in a particular scenario. So it's braking force, and in this question we're going to be asked to calculate the braking force that acts on a truck to actually cause it to decelerate by a certain amount. So we have a big truck and the truck's mass is 8,000 kilograms. The rolling resistance of the truck, or the coefficient of friction of the truck against the road, is going to have a coefficient of friction of 0.1, and there's going to be a deceleration of 3 meters per second squared. So that's going to decelerate. Now the first thing to do when faced with something like this is probably draw a free body diagram, which is a little diagram that contains nothing but the actual forces that are in play here. We will have a force going this way, opposite the motion of the system, if you like, that's caused by friction. So that'll be the friction force. Once we start to activate the brakes, we'll have a braking force. And if you remember, this is a deceleration. The thing's actually going at constant velocity that way when it starts to decelerate. Now a deceleration in comparison to that direction is -3 in that direction, or actually if we do it in that direction we could call it +3 or just 3. And that's what I'm going to do. So this deceleration I'm going to interpret as being an acceleration in the same direction as my forces here and I'm going to call that A there. Now this acceleration is being caused by these forces, or a combination of these forces somehow, and we know that by Newton's laws any force that's causing an acceleration will cause a reaction in the opposite direction that is equal to the mass times the acceleration. So that reaction force is going to come this way, and it's going to be FA, I'm going to call it, for force that's causing the acceleration, and that is going to be your mass times acceleration. This is sort of a notional reaction to the force that's actually causing the acceleration, but it's how the systems work, it's how Newton modelled it, and it works out in these examples. Slightly tricky to get your head around sometimes, but if you always get it into your head that there will be a reaction force opposite the direction of the acceleration that is equal to the mass times acceleration, then you won't go far wrong in these types of questions. So what do we do now? Well, we can say that FB, the braking force, plus the friction force is in this direction, and that's going to equal the stuff happening in this direction, which is the acceleration force. If we have a margin on here and FB is what we're after, so we don't know that yet. Friction force, well, that is the coefficient of friction times the normal force at play in this scenario. So the normal force is going to be the weight, if you like, of that truck. So we're talking about the coefficient of friction times mg, which will give us the weight of the truck, and we've got Fa, which we know is going to be the mass times the acceleration. So what else can we know? Well, we know that A is going to equal 3 in this instance, meters per second squared. We know that mu is going to be 0.1. We know m is going to be 8,000 kilograms, and we know g is going to be 9.81 meters per second squared, or whatever you want to put it in. So I can start to substitute some of these into my formula, and then I'm going to rearrange it to make FB the subject. So I have got FB plus friction force, substitute in for FF, and that's mu mg, and the force causing the acceleration we're going to substitute in ma. So what we got then, we need to rearrange slightly to make FB the subject, so we've got ma take away mu mg, which means we've got mass times acceleration, which is 8,000 times 3, take away 0.1 times 8,000 times 9.81. And if you work that out, it should give you what you're after, the braking force in newtons.